All right, let's begin. Okay, now I do want you to pay attention if you're talking. You do that outside, you don't have to do it in here. Yeah? First lesson back. Let's focus. There's only a couple of chapters left, 14, 15, 16, 17, and you're done. And there's probability, I did say it is easy to take, but listen. And hopefully it makes a lot more sense and then you can answer the questions. I am going to give you one of the extended response questions. I think it was 2012, I think it was, I can't remember now. But that was answered poorly, but it was a really easy question to me. It's very straightforward. And so if you understand the theory, it makes much more sense. Okay? Let's start off. Binomial distribution. We're focusing on today expected value and the variance. Okay, if you know the variance, you can find standard deviation. So, these are your 3 dot points, but really it's just talking about discrete probability. You need to know how to find expected value, variance, standard deviation, and what the distribution is. Now, in discrete probability, I showed you that there is an example of discrete, which is binomial. When we talk about discrete, we are including binomial, including conditional probability. All that is applied into discrete. That's why if you look at your dot points, they fall under discrete, and the next one would be continuous. Okay? So we're still in discrete, and what you can see here says in hyphen number 2 that I'm putting here, it says binomial, oh, there we go, BINP. That just means that you are distributing it by a binomial problem, meaning you only have 2 outcomes. N, which is your number of trials, P is the probability of success. Okay? I'm just noting that down just so that you remember that I did say when you answer the questions in your exams, the way you write it, that's your approach. So if you tell them that you're using binomial distribution, you would say X is distributed, and that's what that symbol means, distributed binomially, and then the MP. Okay, so whatever it is. But that guarantees your mark already. Okay, normal to 2-mark question, and that's your first mark by saying that you know it's binomial. Okay, this is an example of discrete. So I thought I'd just put that out there so you pay attention to that. Let's just do a bit of a reminder again. Binomial distribution. Remember, it follows Bernoulli sequence. What is a Bernoulli sequence? You got each trial results in 2 outcomes, so you either have it or you don't. Either get a 3 or you don't. You either succeed or you don't. Okay, it's always 2 outcomes. The probability of each outcome that you're looking at is consistent. It is the same throughout. Okay, so it's consistent or constant for all trials. And then lastly, all trials are independent. What does it mean? It just means that every trial that you do is like a new trial. It doesn't matter what happened before. That's a Bernoulli sequence, and if you follow Bernoulli sequence, which I showed you through a tree diagram, where this formula came about. Okay, so I gave you an example of flipping a coin, and I showed you, or rolling a dice, getting a 6 or not a 6, I showed you how this formula came about. If you've forgotten, go watch the video again, or look at that PowerPoint again, so it makes sense where this formula comes from, or memorize it. Okay? And don't forget that nx is a combination, so not all the different ways, or the number of different ways you can rearrange whatever you're looking for. So out of 5, if you wanted 2, how many different ways can I have 2 success and the rest fail out of 5? That's just the combinations. So nx represents combinations, and if you've forgotten, this is how you find it out. N factorial over x factorial times n minus x. What is x? X is the number that you want. Okay, so for example, I could say that you've got a total of 5, and out of those 5, I want 2 success. How many different ways can I have succeed, succeed, fail, fail, fail? That's what I'm saying. So, oops. So what I'm saying is I've got 5 possibilities, and when I say x equals 2, I'm asking what's the number of different ways can I have this? Because I just gave you one order. That's 2 success. I can have it as succeed, fail, 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 succeed. That's one combination. So how many different combinations are there? How do you work it out? That's what this formula is for. Okay? So now you've got your binomial distribution. That's the formula to find out the probability of the number of success you want. Okay? So we understand, okay, so that's binomial. Now let's look at it visually. Let's ask ourselves, what does it look visually when we're talking about distribution? What does binomial distribution look like? Because that's what you need to do. Okay? And I'm going to show you how to do it in a calculator as well, so you can start to get an idea of what it looks like. So this is the first part. I described what binomial distribution was. Now, we're going to look at the distribution, which is the first step. And the second part is I'm then going to get you to look at the expected value and the variance. Okay? So this is part of the textbook. It says construct and compare the graph of the binomial probability distribution for 20 trials. In that line, if that sounds confusing, it's not. All it's asking is, if I had 20 trials and you knew it's discrete and you knew it's a binomial problem, meaning you only got 2 outcomes and you've got 20 trials, right? They're telling you, find out if the probability of success, whatever you're looking at, is 0.2. If this still doesn't make sense, try to visualize it as a table. All I'm saying is, X is whatever I'm looking at, as in the success. So it could be getting a 6. So out of 20 trials, rolling a dice, for example, I could say roll a dice 20 times. What's the chance of me getting 0 6s? What's the chance of me getting 1 6? What's the chance of me getting 2 6? 3 6, 4 6, 5 6, 6 6s. And it carries on, right? So this is my distribution table. How do you find out the probability? Well, let's say if you did know it was binomial, you either get a 6 or you don't get a 6. Then you follow the formula, and how I've got 0.012, you would say probability of your success, and you want 0 of them. So let's say you want 0 6s. Out of your trials, you've got 20. I don't want any 6s, so I don't want any success. That's a probability of success, 0.2, because that's what they're saying. Let's say A was 0.2, the probability of success was 0.2. So you got a good 20% chance of getting your 6, but you don't. 80% chance of you not getting it. How many of these 6 you want? None. How many of the ones that you don't want a 6? 20 of them. This is your formula, plug that in your calculator, and yes, you get 0.011529. I've just rounded off to 0.012. Okay? So that means if I then said, find x equals 8, meaning the probability of success being 8, so that means I get 6 8 times, okay? What's the chance of me getting that? What's the probability of me getting that? You do the same thing again. And you'd say, it'll be out of 20 trials, or out of 20, I want 8 of them to be successful. So that means I've got 12 that are not successful. So I either get a 6, or I don't get a 6. And you figure that out in your calculator, you get 0.22161. Okay? Now, yes, in your calculator, you can calculate all of this much quicker than what I'm doing. I'm actually doing it individually. Yes, you can do it in a calculator. And you can do it through a spreadsheet. And I'll show you how to do it later on the calculator. But what I've done here is I've got it to calculate all for me from 0 to 20, and I know the probability of each one. Why did I do that? Because I want to show you the distribution. When you say probability of success is 0.2, what does it look like? If I plot that in the graph, this is what it looks like. And what I want you to notice is right here, 0.2, this is 0.8, so 0.2 is about here. So you can see, when you say 0.2, probability of success is 0.2, it makes sense that most of your data will be about 20%. 20% of what? 20% of the number of trials you have. What's 20% of 20? Well, 20% of 20 is just like saying 1/5 of 20, which is about 4, which makes sense. About out of the 20 trials you do, if you knew you have a 20% success rate, you'll expect about 4 would be about the 20% rate, like you would be successful. About 4 6s is what you expect. If that confuses you, another way of explaining it is saying, if I flipped a coin, you either get heads or tails. If I said I flipped it 10 times, and I asked you, what's the chances of me getting tails? You would say 5. Out of the 10 trials, you'd say 5. How did you know that? You did 50% chance of success times the trials. So you would have got 50% of 10, which is 5. Same thing here. What if I told you that you had 20 trials, and the chance of success of getting a 6 is 20%, then how many 6s do you expect to get? Then you would say, oh, well, 20% of 20. 20% of 20 gives you 4. So you expect about roughly 4 is where I would get my success. And hence probability of success is 20%. Okay? So what I want you to see is the distribution of the data. It makes sense. So if you told people that your success is 0.2, which is 20%, that's pretty low. Which is why most of your data is in the lower region. The chances of you getting 26s in a row, very low. Because you told me that there's a 20% chance of getting a 6. So what's the likelihood that you're going to get 20 out of 20, 26s? It's unlikely. It's more likely that you get 4. It's more likely you get none. It's more likely you get 1. But it's very unlikely you get 10, 12, 14, or 20. This is what this means. When you say probability distribution of 20, probability of 0.2, and you know it's binomial. Let me show you this on a calculator so you can see what I'm saying. Okay. On a CAS. So, what you can do is you go to your menu and you go to a spreadsheet. Okay, so you enter a spreadsheet. Now, I'm going to give a name to each one of these. I'm going to call it, I don't know, variable X. Okay? And then let's say I want to calculate the probability, so I do prop for probability. Yes?
Is there any like general decay equation that maps out that?
No.
Well, again.
I will talk to you later. Okay. I'm going to call this variable and probability. Now, variable, which is your X values. So remember, I was talking about your X success values from 0 to 20. So that's what I'm going to do. I type in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to stop at 10 for now. I'm just going to stop at 10 for now. So let's say, how do you work out the probability? Like, you can do it manually for each one, or you can tell them to calculate it for you, like an Excel spreadsheet. So I'd say, all right, to figure out the probability, I want it to equal 2, and you type in your formula. Now, you know it's a binomial distribution, so you're going to go to menu. It's under statistics. It's under distribution. And what type of distribution you want? You want binomial PDF. Why PDF? Because PDF calculates per event. So it's 0 or 1 or 2 or 3. CDF is an interval. So if I said more than 10 or less than 10, then you calculate CDF. But you want to know individually. So I go to PDF, and I say number of trials. Well, I got 20. Probability of success, I told you was 0.2. And my X value, I'm starting at 0. Okay, so if I go there, press enter. Whoops, what's going on there? That doesn't make sense. Oh, I know what I've done wrong. Let's go back here. I'll tell you what I've done wrong. Whoops. Alright, let's do it again. Equals. Menu, statistics. I want distribution, and I want binomial, which is still the same, 20.2, but the variable, I want it to be var. Where is it again? There you go. That's what I wanted. Okay, because I put 0 and it means it only calculates for 0. I put 1 and it only calculates for 1, but I wanted to calculate based on what my variable is. And there we go. Press enter and it'll fix everything again. Okay, so if you have a look at this, this is just basically telling me each probability of success. If I knew the probability of success was 2, 0, 1, 2, 3, these are the number of times I'm going to get these success, then you can calculate it, calculates it for you. But I want you to notice the probability. Have a look, it goes from 0.05, 0.13, 0.2, 0.2, and then it decreases. So it increases, then decrease, 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 decrease. Now if I go to 11, and then I go to 12, then I go to 13, then I go to 14, I go to 15, and then you see it's 1.6. Have I gone somewhere wrong? What do you think this 1.6, just in case you misinterpret this when you type in your calculator, should be getting smaller or should it be getting larger? Smaller. But it is smaller, it's just the way they've written it on your calculator. If you just hover your mouse over, yeah, I know. So just pay attention to that. That is actually just e to -7, so it's actually getting much smaller. Whereas this was to -6. This is now -7. Okay? And then you can carry on 16, 17, oh whoops, 16, 17. And each one is getting smaller and smaller. Okay? So what I'm trying to say is it made sense that when we said probability of success is 20%, it's very unlikely that you're going to get 18 sixes in a row. It's very unlikely that you're going to get that. Okay, no matter which combination you want to put it, it's very unlikely if the chance of getting a 6 is only 20%. Okay? And now if we were to distribute this, if you wanted to visualize this is what you're going to do. Go back to menu, go to this graph. Now, on the left-hand side and right-hand side, that tells you your axes. If you want to click on your axes, we wanted probability, because that's what we're measuring. Probability, we want to see that distribution. So probability, I've named it as prob. Okay? And then on the bottom, I want to put out my variable, which I only typed from 0 to 18. So I'm going to go var, because that's the one I labeled. Okay? And as you can see there, that's just the distribution of all my data, which is not all 20 of them, but it only goes up to 18. And what you can see is this is the graph of a 0.2 probability. This is your binomial distribution. Okay? So that's how you do it in your calculator. Let's go back to theory. So, this is my graph. What I wanted you to pay attention to is that these are your three graphs. When we said probability of success is 0.2, that's what it looks like on the left. When I say that my probability of success is 0.8, which is top right here, you can see that most of your data is skewed to the right. And then if I asked you probability of success is 0.5, it makes sense that you get this sort of nice symmetrical look. Then I want you to pay attention to, which I was alluring you to, they have different names. They're called positively skewed, negatively skewed, and symmetrical distribution. The counterintuitive part here is when you say positively skewed, you're just saying that that tail end is being skewed in the positive direction. This is, the tail end is skewed negatively. That's why we call it negatively skewed and positively skewed. Okay? But the one thing I want you to pay attention to was this, which I sort of hinted out in the first part of the slide. I said that 20% of 20 was 4. So it made sense that you expect most of your data will come at 4. If you look at the peak on this side, this is your most peak, and that's at 16. Which makes sense, because if I asked you to find 80% of 20, it is 16. If I asked you to find the peak on this one, 50% of 20 is 10. So it makes sense that most of your data will likely to occur at 10 trials. That's what you expected. Which happens to be the next part. I told you I was going to introduce you from distribution to expected value and variance. This is how you can remember expected value, because if you understand it, it makes sense. So here, the expected value is found by multiplying the number of trials by the probability of success. And I've shown you here, 20 times 0.2 is 4, 20 times 0.8 is 16, and 20 times 0.5 is 10. Okay? That's what they're trying to tell you. And so therefore that lends you this formula. The expected value is just the number of trials you have times the probability of success. Now, there is a proof to this, and this is what I'm saying. You can either take what I've just shown you here and memorize these two formulas right there. Okay? This is probability of success. This is probability of failure, or not getting what you want. So, you can just memorize these two, or if you want to know where it comes from, because remember I said that everything goes back to chapter 13, where expected value was equivalent to the sum of x times your probability, and I told you that variance was your expected value of your original data minus what you expected, and you squared it so that you don't get that negative. These are the theory. You want to know the proof? They're using that theory, and you can get these two. Now, if you're interested in it, and I'll show you very briefly, I'm not going to go through it in too much depth, but I'm going to go through it briefly so you can see what to expect if you are going to read the pages. This is what you're going to expect if you want to understand where they all come from. And remember, it's beyond the scope. You don't have to understand it. It's just nice if you wanted to. Okay? But here we go. In order to actually understand this, refer, and I'm bolded in red, please refer to page 6112. That will show you the proof for the expected value and the variance. Now, in order to understand it, the first part of it, if you're reading it and you're sort of lost already, it's because you need to understand what binomial theorem is. Binomial theorem, in case you don't know what binomial theorem is, I'm going to briefly, just very quickly whip through this, okay? Remember back in year 9, you would have started with linear, mx plus c, y equals mx plus c, yeah? And then you went to quadratics, they taught you how to expand ax squared plus 2ab times b squared, right? So you learn how to expand x plus b squared, and you learned the cubic. ax cubed plus 3a squared b plus 3ab squared plus b cubed. Yeah? That's what you learned in all the way year 9 to year 11, but you didn't need to learn quartic and quintic and septic, right? Then we showed you Pascal's triangle. Well, I showed you Pascal's triangle to figure out the coefficients. Now, conveniently as well, in Pascal's triangle, there is a pattern that you can use combinations. See, this is the same thing as saying 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. All of that. These are combinations you've got out of 0 trials, and I don't want anything. How many different ways can I do that? Well, there's only one way. Okay? Every one of these numbers here represents combinations. Now you can type that in your calculator and you will get the same numbers as Pascal's triangle. Why do you want to know this? Because it leads into, so for example, this is 1, 2, and 1. What you're going to get is in Appendix A 764, again, you can go through this slide if you want, but I try to explain what they're trying to explain, okay? This is how you would have learnt it using Pascal's triangle. You would have known it's 1, 6, 15, 20, 15, 6, 1. That's the pattern through Pascal's triangle. And in terms of your variables, it always made sense. X to the power 6, x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, and then x to the power 0. And then similarly, you've got b to the power 0, b to the power 1, b to the power 2, b to the power 3, and this has always been your pattern. For all binomial expansions, it's been the same. If you have a look at these ones here, it's 3, 2, 1, 0. 4, 3, 2, 1, 0. That's the same thing. It goes over and over, the same thing. So therefore, you can actually write the expansion, binomial expansion, in a formula. And this is what they were trying to show you, that from here, since you know that 1 can be written as the level 6, so just go back to Pascal's triangle so you can see row 4 connects to 4 different options. 0, 1, 2, 3, 4. So that means by row 6, if it's power 6, you got row 6, 0, 1, 2, 3, 4, 5, 6. So that means you can write the binomial expansion x plus b to the power 6 as this. Now that you understand that, then you can go back to saying this is the general formula, because it is exactly the same as your binomial distribution. You see, each of these powers, x to the power 6, which is here, x to the power 5, x to the power 4, it drops down by 1 each time as you increase these variables. And because of that, you can write your general formula as this over here. And that looks very similar to your binomial distribution. Now we can go back. Okay, so this is what I was saying. If you really wanted to understand this, Appendix A first, binomial theorem, And then you go to page 612, then you can really understand what they're saying, because this is the first slide. That's the first step, and I can see why a lot of students will find this difficult to understand if you did go to page 612, because how'd you go from there to there? Okay, and this is all they said was using the binomial theorem, the sum of probabilities for a binomial random variable x with parameters n and p is given by, and I know that if you read that, you'll be like, what is it talking about? And I agree, it's confusing. Okay, so the first step is you have to understand binomial theorem, which is this, which I just showed you where it came from. And then you're going to connect this with the probability of x equals x. Because then you can say, since it's a plus b to the power of n, if this is your distribution that you've learned, this is what I've taught you, binomial distribution, then you can say, you can simplify, this is your a and that's your b. All to the power of n is exactly the same. I'm just rewriting this. So these two, I'm just rewriting with different variables. So instead of a, I have p. Instead of b, I have 1 minus p. That's why it's a plus b to the power of n. Now why do you want that? Because notice negative p plus p will cancel out. You end up 1 to the power of n, but you know that 1 to the power of anything is 1. So what is this talking about? This just means, and this is exactly the same theory we've been saying, the sum of all probability has to equal 1, which makes sense. In your data, if you add it all, it has to equal 1. Okay? If that was confronting already, then I highly recommend you don't look at page 612 to try to understand it. It's quite a bit. Because if you do carry on, this is exactly the next steps. And they skip a lot of steps in between here. Okay? For you to factorize, so when they say cancelling the x's, they mean to cancel that x, that x. So you really have to take a bit of algebraic thought. But if you're interested, by all means, have a look. It really is nice to see where the formula came from. And I tried to use arrows to show you what they've done. I tried to show you where they all came from and what they were trying to do. So how did they go from this to this? And I tried to show very quickly, just in terms of where it all came from. But again, it's a lot of algebra, and you do not need to know this. Okay, it's just nice if you wanted to. Okay. Anyways, having said that, I can imagine that expected value, where the formula came from, you'll be saying, I don't actually need to know, and therefore the proof and beyond, that's your variance, and there's another proof for that as well. You can have a look at it. Same thing, page 613. Otherwise, just memorize this for me. That's it. Okay, so out of all that proof you didn't need to know, all you need to know is, this is how you find the expected value, and it's how you find the variance. But if you wanted to know where it all came from, yes, you can still use the theory, and it shows you. Now that I've taught you pretty much almost everything I needed to tell you, let's have a recap. I taught you what binomial distribution is. I taught you what the distribution looks like graphically. I taught you where the expected value came from and how it looks. Okay, how you sort of logically figure it out. Number of trials times the probability of success. I didn't tell you how the variance came about because the proof to it is a bit too crazy at this point. But I did tell you earlier on in chapter 13 what variance really is. It's just the measure of spread. So, now that you know that, that means you can find standard deviation, which is the square root of variance. We can now answer all the questions then, because it's all about analyzing. They're going to give you a question, and your job is to analyze the problem and use those formulas to answer the question. So let's have a look at this first one. Pretty easy. Standard textbook question. An examination consists of 30 multiple choice questions, each question having 3 possible answers. A student guesses the answer to every question. Let x be the number of correct answers. And that's key. Let x be the number of correct answers. So that means it's binomial if you get it correct or you don't. You either get it correct or you don't. 2 outcomes. So again, it's binomial straight off the bat. Right? x being the number of times you get it correct. So you're going to get 0, 1, 2, 3, 4, whatever. Okay? Now the question asks you to find how many will she expect to get. Okay, because it's so straight in your face there. They're just asking you to find the expected value, which you would remember from the formula is the number of trials times the probability of success. Now, let's have a think about it. How many trials do I have? How many times am I going to do this? How many times is... There are 30 questions, so hence 30 trials. What's the probability of success? If there's only 3 possible answers. Yeah, 1 out of 3. So if you had to answer the question, first one, n equals 30, p equals 1/3, and you know the expected formula was n times p, then it's the third times n, which is done, too easy. Okay, so you've got your 10 correct answers is what she would expect to get in the probability of success is 1/3, if she guessed every single question. Okay? And then to find your variance, the formula was NP and also times the probability of failure. So, failure, which was, this is your N, times your P, failure was 2/3. If you times all that together, that was your variance formula, 20 out of 3. Easy. Textbook question. And that's your 14B, that's what you'll be doing. Right? And let's move away from that. I'm now going to give you 2 past exam questions. One, which is the easy one, multiple choice question. And the second one, you're going to have to think about. Okay? Here we go. 2008, exam 2 multiple choice question. Pretty straightforward. You should be able to tell me the answer straight off the bat. Or figure out what you have to do. If you have a calculator, it'll be faster. Question 5. Let x be a discrete random variable. So already you know it's discrete, not continuous. With a binomial distribution, so they spelled it out for you. It says binomial. The mean, which is the expected value, they told you the mean is 1.2. And the variance is 0.72. Now they ask you to find what is n and what is p. Not a hard question if you just learned what I just taught you. I told you what binomial theorem is. I told you what the distribution looks like. And I told you the expected value and variance. Use that to answer this. 68% of students that year got this question correct, so you can't tell me it's a hard question. Okay? You can use a calculator, might make it quicker, or you can do it by hand. Go. I'm going to give you, it's now 2:15. You've got 8 minutes with me. I'm going to give you probably a minute and a half. Let's go. Not a hard question. All right, let's go. Now, if you had attempted this question, there's a couple of ways to do this. You should have known straight off the bat that B and D weren't possible answers. Why? Because the mean, which is the expected value of a binomial distribution, is n times p. They already told you it's 1.2. So that means if I got 3 times 0.6, it should equal to 1.2, which is not true. So obviously you knew 2 times 0.4 is also not 1.2. But potentially it's 4 times 0.3, potentially it's 2 times 0.6, or potentially it's 3 times 0.4. But you're still stuck. You still have no clue on how to answer the next question. Now you can either do trial and error here. You can say variance of x is n times p times the probability of failure, and you can stop until you get your answer. That perfectly works as well. Or, logically, you've got 2 equations. You've got np times 1 minus p equals 0.72. Type in your calculator, 2 unknowns, 2 equations. Solve. And you're done. And if you did that correctly, Is your answer? Good. And nothing to be proud of because 68% of students said you got it, so you should have got it anyway. Okay? Now, this is the question I want you to do. Vika, 2012. Now, I only chose the first three of the question because the first three you have the ability to do it now. You haven't learned the next part yet. So, these three questions you can do. Every one of you can touch extended response questions. And I told you that in exam 2, you generally get 4 questions from the past exams, unless they change this year. Generally, extended response questions get 4. And out of those 4, generally one of them is probability. We just don't know what type. You can get either normal distribution, continuous, discrete, or binomial. You don't know. And this year you got sampling as well, so it might be sampling. More likely to be sampling, I reckon. But you got those. One question out of your 4 is going to be a probability type. And if you're well prepared, you will be able to do normal, binomial, discrete, or continuous. The only thing I can't tell you is sampling, because I have no idea what questions they'll do. But out of the 5, you can do 4. So how hard is that? Okay, so let's have a look at this one. Extended response question. Normally you get what, 10 to 13 marks for per question. Let's have a look at this one. 3, AI, and double I, and triple I. I want you to read the question. It's very similar again. You got number of questions, and you got possible answers, and they asked you, what is the probability that Steve will answer the first 3 questions of this set correctly? Read the question properly. And then, second part, find the probability that Steve will answer at least 10 of the first 20 questions of this set correctly. And then the third one, use the fact that the variance of x is 75 and 16 to show that the value of m is 25. Okay? So I want you to have a think about it and try to do this one. Okay, now if you do run out of time, because we've only got about 5 minutes left, if you do run out of time, I have written all the solutions for this on the PowerPoint so you can have a look at it. Okay? But I do want you to tap this. You should be able to do this with the current understanding that you have. Okay? Have a go. I'll come around and clarify things for you.
First one. Let's start off with what's the probability of success? Like, what are we looking for? It could be anything, but how do you know? So if you chose a question, how many possible answers do you make? There's 4 of them. Now, which one of them is correct? 1. So the chance of you getting 1 correct is a quarter. Regardless of the number of questions you have, the chance of you getting 1 correct is 1 quarter. No, you think. Think about it. I want success, success, success. Tree diagram. Oh! No, you're not meant Second one. Now you really got to think about it. You can either draw a tree diagram, or, which you don't do it, or you also understand that I showed you the distribution data. You came from that diagram. So really that question there is how do you use the distribution to answer the question? Yes, and what did I tell you about? You can either use a calculator to find one instant, or you can find an interval. Binomial, good. You got binomial PDF, which tells you one instant, or you have binomial CDF, which tells you the interval. And what interval are you looking for? 10 times 2. you just write 10 plus 1. Probability of success, you already know, 1 quarter. Number of trials, you know, it's also 1 enter, and you get your answer.
Oh, you need my help? Just for those that are interested. That's the answer for the first one. Success, success, success. There are only 4 options. It had to be 1 out of 4 to succeed. So it makes sense. It's a quarter times a quarter times a quarter. Second one, greater than 10. So of course you want greater than 10. So you just type in your calculator, CDF, interval. I told you, it's not PDF, it's CDF. It's an interval from 10 to 20. 10 to 20. N, P, lower boundary, higher boundary. Simple as that. Okay? Have a look at my PowerPoint. Have a look at my PowerPoint. Have a look at my PowerPoint.
We want help. Do you have password?
Yeah, I do.
Okay. Can you explain to us this? I don't get it.
You don't need to.
But I won't understand.
Pascal's triangle is designed for you to find out your coefficients. 1, 1, 1, 2, 1. Pascal's triangle is this. 1, 1. How you get 2 is 1 plus 1 gives you 2. Next one you should have 3 items. This is your 4th row, so you should have 4 items. So in order to get the next 2, it's 3. 1, 2 plus 1 plus 3. Those are the coefficients for 1, 3, 3, 1.
Oh yeah, makes sense.
Yeah,
You get it?
And in your 5th row, you've got 2 items, so then there's 3 items. 1 plus 2 is 4, 3 plus 4 is 6, 3 plus 1 is 4, which is why it's 1, 4, 6, 4. That's Pascal's triangle. Now what we're saying here is 0, 0. This is combinations, which is the formula where I showed you n is equal to n factorial x factorial times n minus factorial. So in this case, it would be 0 factorial over 0 factorial times 0 factorial. And we know for mathematical factorial, 0 factorial is 1, which is true. This one, let's say 3, 0, just means 3 factorial over 0 factorial, which is 1, times 3 minus 1, which is 3 factorial. And so from here, we know that 3 factorial, that's just 1. So we think it's going to be 1. And 3 divided by 3 factorial divided by 3 factorial, that's 1. So it makes sense that 3 is equal to. And if you want 3,
Sorry?
so same thing again, 3, 1 just means 3 factorial over 1 factorial times 3 minus 1 factorial. 3 factorial is essentially 3 times 2 times 1. This one is 1 factorial, which is 1, and 3 minus 1 is 2. So we have 2 factorials, 2 times 1. Conveniently, these cancel out. It's just, that's why it's that. So this represents that, this represents that.
Thank you.
It is pretty cool.
What chapter and section do I find this under?
This is chapter 14.
Section.
I've actually
Section?
Like
The exercise.
14B, we're on today.
We're on B.
14B.
Yeah.
Thank you.
So you won't even. I won't even.
Whose laptop's this?
Nah, you won't touch it.
Someone just.
So, I got a question quickly.
No! What do you want?
Alright.
Also consider the different combinations of not having 10 or 11. So if you got 11 success, that means you got 9 failures. If you got 12 success, then you have